Alright, in this video I want to take a look at a problem where we would be doing a z-test or a hypothesis test using a standard normal variable, the z variable. So in this problem I have says that a random sample of 50 medical school applicants at a university has a mean score of 31 with a known population standard deviation of 2.5. So a student says, there's our claim, that the mean raw score for the school's applicants is more than 30. So at a significance level of alpha equals 0.01, is there enough evidence to support the student's claim? So again, typically our process here is the first thing we identify is the claim. And in this problem, the student makes a claim that the mean score is more than 30. So we can see our claim written here. And so since this does not have equality, it falls into the alternative hypothesis, and then therefore the complement statement, less than or equal to 30, would be the null hypothesis. Now, typically, if we're taking what we call the p-value approach, then we would need to calculate the standardized test statistic here. So what we would do then is use our formula to find the standardized test statistic. So we'd have our sample mean minus our claimed population mean, and we divide by the standard error. So if I'm doing this by hand, then I would have our sample mean minus the claimed equality in the null of equal to 30, and it would divide by the standard deviation over the square root of our sample size of 50 medical students, and we get 2.83. Now if we look in the kind of a visual interpretation of this, I'm looking at the graph here. If I plot 2.83, our test statistic, our alternative is greater than. So let me scroll back up here. Right, our alternative is greater than, so we're doing what we call a right-tail test. So I could look in the standard normal table that is typically in the back of a book, and I could look to the right of that z-score. We would get 0.0023. So our decision in this case, again, if doing this by hand, the 0.0023 is less than our alpha, so we would reject the null statement. Now, within the context of this application, if we're rejecting the null statement, then we're supporting the alternative or supporting the claim. And I would word the problem in that manner. There's enough evidence to support the claim. Now, if I'm doing this in StatCrunch, right, how would I approach this? All right, now I've opened StatCrunch here. And the way that I would do this in StatCrunch is I would hit Stat. I would go down to a Z-stat. Now I have one sample. And then I have the summary of the summary statistics, right? So I have the sample mean summary statistics. So I'm going to choose that value, and it's going to ask me for the couple pieces of information it's using for the standardized test statistic, right? So it has to calculate the standardized test statistic here. So I have a sample mean of 30, a population, excuse me, sample mean of 31, and the claimed population mean of 30. So when I bring StatCrunch back up here, when I bring StatCrunch back up here, the sample mean was 31. Now we don't know the sample standard deviation, right? So typically what I'm going to do in this case is use the population standard deviation, which was 2.5. Right, and then we plug in our sample size, which was 50. Let me make sure that was 2.5 real quick, guys. Hang on. Yeah, 2.5, and our n was 50. So I plugged that information in. Now, our null hypothesis was equal to 30. Let me double check that. Right, our null hypothesis was equal to 30, so I plug that in. And then I'm doing a hypothesis with the alternative being greater than. So this is telling it to do a right-tail test. And I like to visualize the problem, so I'm going to do a p-value plot. And when I compute, the first piece of information it gives me here is the standardized test statistic, which we found of 2.83. If I come back, we got 2.83. And then the p-value that we have in the right tail was 0.0023. So we can see 0.0023 is that p-value. Now if I go to the graph on the right, we can see the visualization that we had drawn on that prior paper. So here's our 2.83 standardized test statistic, and then the area to the right is our p-value of 0.0023. Now, let's suppose we were doing a problem where we had the data, right? So I'm going to pull up a problem real quick here where I have the data. So here's a problem. It's going to ask me to do all the same stuff. What's the standardized test statistic? What's the p-value, right? What's our decision? But in this case, I'm given the data. So over here, I'm going to click on the right, and I'm going to open in StatCrunch. And it's going to open the data in StatCrunch for me. So I'm going to tell it var1 was the data, right? That was the name of my column. And because I know this population standard deviation, I'm going to go ahead and type that here. Now let me click back to the problem, and we are told that the population standard deviation is 9,900. So let me go back to that. Oops. I'm going to go back to that, and I'm going to type in 9,900 here. So our claimed population mean in this problem, the claimed population mean was that the national average is more than 81,000. So I'm going to plug in the 81,000. And then based on that value, the alternative is a greater than. So I'm going to make sure I choose the alternative as a greater than. I like to do the p-plot, and then I'm going to go ahead and compute. So for this particular problem, we can see the standardized test statistic would be 2.2. Here would be our associated p-value, right? And then the visualization of that is something of this nature. So based on that p-value being less than the alpha of 0.1, we're going to reject the null and make our interpretation. So that is how we would do a hypothesis test with a z statistic using either the summary statistics or the actual data we open in StatCrunch.